Let's say you have an important math test tomorrow, but today is your best friend's birthday party. In this case, there are two variables, study time and time with friends. Choosing either option will result in both a net gain and a net loss.
As you can see, picking either option will result in what we term conjugate variables, or in common terms, trade-offs. Your choices would result in both a net gain and net loss. Now, let's apply the situation to electrons. According to the Heisenberg uncertainty principle, the uncertainty in position times the uncertainty in momentum has to be greater than or equal to Planck's reduced constant over 2. This means that there's no way to determine both the momentum and the position exactly without some degree of uncertainty. To know the exact position of an electron, photons hit the electron and reflect light back into our eyes. Now, if we apply that to a photon through this equation, high energy of the photon implies low wavelength since h and c are constants. But if the photon has high energy, it will have a greater capacity to bump into the electron and move it, which changes the electron's velocity. Relating velocity to momentum, we can see that changing the velocity changes the momentum, which increases the uncertainty of momentum. So even though we can get an accurate understanding of the position, there is an uncertainty in momentum. But if we hit it with a low energy photon, we can't see the position of the electron clearly, but we can hit it a few hundred times and get a general velocity through repeated plugins of change in displacement over change in time. This demonstrates how momentum and position are conjugate variables. We can never get the exact value of both.
Understanding the Heisenberg uncertainty principle is phenomenal into understanding more deeper topics like wave-particle duality and quantum mechanics. So next time a budding scientist like you gets pulled over by Heisenberg and he asks you, "Do you know how fast you're going?" you can always say, "No, but I know exactly where my location is." And that concludes the Heisenberg uncertainty.